Hey guys, it's Vince. Today I'm on a different version of my testing bed, and this is Shan's system from WERKZ holsters, and I'm doing finalized testing on checking his VFD with his dual relay configuration with an actual spindle to make sure everything is functioning. Now this is what I do with every client system that I produce. And why do I do that? Because I want me to experience a problem before any of my clients do. That's common logic. That being said, after going through all this, I thought to myself, one of the biggest questions that I continuously get asked is how do I diagnose, or just for that matter, check PWM voltage on a G540, or for that matter, any drive, because all of this information is applicable to any driver, meaning any stepper drive, servo drive, whatever it may be, or breakout board that utilizes PWM voltage to actually manipulate the speed of your spindle. So I pulled out the multimeter, and you can see we've got that right here. It's a Fluke 179 True RMS. I set everything up just as I would do the typical mock-up. You can see what we've got here. Here is Shan's system, UC400 here, just held in place with masking tape to make everything as clean as possible. DB9 double shielded cable going over to the VFD, and we can go over this briefly. I've already done this on the first version of the controller he purchased. You can see how I've machined in a nice hole, and that's so we can let all our wiring in. You can see the DB9 connector that goes to the DB9 cable, and then it breaks out. DCM is white lead, reverse is blue lead, forward is black lead, ACM orange lead, and 10 volt is purple lead. Now, you can see we've got our brass thumb nuts here. Brass thumb nuts hold in the mounting system for the DB9, which is actually allocated to a steel bracket. We've got 632 screws there with standoffs. Everything here is set. We can then apply our cover and screw it into place when final assembly is done. So that's all done. To take this to the next level, and many of you know this from the first video, all of my systems come with wiring diagrams. So naturally, end users can actually go in and make sure that they can go through, and if they have to work on their system at all, they can perform that themselves without having to guess. And you can see here Mach 3 settings, along with all of the color allocations to whatever DB9 pin is connected, and where exactly it goes on the VFD. Now, I've got nothing plugged in yet in terms of the VFD. The system is plugged in. I'm going to turn it on. It's on. It's going to go to green light. I do have the fan disconnected so I can speak over the system. I'm going to power on now the UC400. You just heard the relays kick on. You can see we have a green power LED on the UC400. Once communication happens, you'll see it go to solid blue. There'll be another blue LED. And then we will turn on the VFD by just simply plugging it in. In about 3 seconds, she's up. We're good to go. Now I'm going to come over to the PC. We'll get everything started. Okay, you just heard the relays kick on again, and now you can see we've got the blue communication LED on the UC400. Everything is set. I'm going to turn my multimeter on to DC voltage readings. Now this is why I highly recommend you get a precision multimeter, and always get the best one you can afford, because at one point or another you're going to want really accurate readings, and with CNC use, accurate readings are a must. So the first thing you'd want to test, and again, I'm not going to go into the settings here of how I've got spindle control and all that, because I've already covered that in a previous video. What I am going to do is remove the cover here. Now that the multimeter is set up, I want you guys to pay close attention to this 10 volt and the ACM. ACM is essentially your DCV negative. 10 volt is the positive of providing 10 volts. Now there's a misconception that the G540 or any drive usually supplies that 10 volts, and usually it does not. PWM voltage really simply is just a percentage to get you to manipulate RPM. Let me explain. 0 volts would represent 0 RPM on your spindle. 10 volts would represent 100% RPM, or 24,000 RPM in this case for this spindle. Anything in between that would just give you a differential of that RPM, meaning the voltage would give you a differential of that RPM. So 5,000 RPM would be just a slight percentage of between 0 and 10 volts. Okay, so now what we're going to do, now that I've explained how that works with PWM, I'm just going to apply my probe on ACM terminal and the red probe on the 10 volt terminal, and you'll look on my multimeter and it's registering 9.97, 9.96. It's fluctuating slightly. And you can see we're essentially getting 10 volts output from the VFD. Okay? Now, why is that important? It's important because this 10 volts from the VFD is actually going to be feeding into the G540 so that the G540 can step down that voltage accordingly to whatever RPM we decide to run within Mach 3. So essentially, if I come over here now, and this is the beauty of working on a system like this, is that you could see that solderless DB9 connector, and it's got screw terminals on top. So everything can be connected and I can still get voltage readings. Okay? So what I could do here is if I didn't know what I was doing, I could look at the diagram and I could say, oh, okay, what is this? Oh, okay, I could go in here and then I would just connect and connect, and you could see right here, we're at 0.04 volts. Okay? So right now, the G540 is putting out virtually no voltage under its PWM. So what essentially is happening is the voltage that's being output by the VFD, that 10 volts, is going through the cable into the drive, and then the drive is regulating that 10 volts. Meaning it's regulating the output of what's coming from the drive to this drive, and then regulating that to that appropriate voltage to control the speed for PWM. Now, what most guys believe is that the drive itself is producing 10 volts, and it's not. So now you understand how it works. The G540 is just working with the voltage output from the VFD, which is 10 volts, hopefully, or 9.9697 in this case, and then it's regulating the amount of voltage required to actually regulate the speed of the spindle. So let's see how this works in real time. You can see here I have 0 spindle speed set up. I'm going to reset the e-stop, and I'm not going to input a spindle speed. I'm just going to click on the on button. Now our spindle's going, and I didn't type in a spindle RPM yet. We're at 1100. Where did that number come from? Many of you are going to ask that. Well, under the minimum PWM setting, and I'll show you that right now, inside of Mach 3, I have set that to 5%. See that minimum PWM at 5%? That 1,000 to 1,100 RPM is basically 5% of the 10 volts. And that's exactly why we're getting that RPM. Now, how can I convert that RPM to voltage from my PWM? Watch this. We can click on apply. I'm going to hit our reset and naturally go through the motion. Again, I'm not going to put in any RPM. I'm just going to have it start. We can see we're at 1100, 1128. And you can see we're now 0.52, 0.49, and it's just fluctuating. You could also see the RPM fluctuates slightly. And that's due, yes, you figured it out, to the voltage fluctuating. And it's very slight fluctuation. You can see that the spindle is on, it's rotating. You can also see the spindle is forward rotation because of the VFD. You see FOR on there, means it's spinning forward. So now what we're going to do is we're going to go to 5,000 RPM. And now you'll see 5,000. I'm just going to hit enter. Now we hear a tape really zoom in. We're at 4,700, between 46, 47. Now we're teetering. And that's totally normal because you're going to always have slight efficiency loss as far as voltage. So let's see what the 540 is putting out right now. Okay, we're putting out about 2 volts and it's fluctuating. See that? So that 1.9 to 2 volts equivalates to 4,700, 4,600, in between that RPM. And you can see exactly now how this works. So let's look at this in a practical example. I'm going to turn this off. And as I turn it off, we'll take our measurement again. And you can see your voltage is down to basically 0.04 again. Okay? And yet if we check our voltage over on our VFD, once again, black lead ACM, red lead 10 volt, you're at 9.97. Okay? So we know the VFD is working perfect. We know the G540 is working perfect. Many guys go, well, how would I get 100% efficiency in terms of the drive itself is only able to put out maybe 9.4, 9.5 volts because we're getting that efficiency loss. It's not absolutely perfect. And if we have that efficiency loss, of course, you're going to see it in your RPM. That being said, I'm just going to cut this tape because it'll get crazy on us. If I go to 24,000, it still might get crazy, but we'll see. And then what I'm going to do is show you what the voltage differential is. Okay guys, I just removed the tape from the spindle because we don't want any catastrophic events with the tape coming out from the G-force when it spins. What we're going to do now is we're going to turn up the spindle to 24,000 RPM. And once again, we'll take a voltage reading from the drive itself and see what differential we have and see what actual RPM we achieve on the VFD. So if we come over here to spindle speed, here we go. She's spooling up. So we're only able to achieve 22,824. Now a lot of guys go, wait a minute, that's a pretty big difference from 24,000. It's really not. It's basically only about a 5% difference. Let's check our voltage on the G540. And there's your voltage difference right there, gentlemen. We're at 9.44 volts output for PWM voltage on the G540 at 100% RPM, or 10 volts in the maximum output that the 540 would put out in order to achieve that speed. And then when I come over here and take a measurement here, once again, black probe on ACM and then red probe on 10 volt, and you can see the difference. So we're at 9.96 on the VFD, no real fluctuation, and we're at 9.44 volts on the G540. And that explains why we're only able to achieve 22,824, even though we put in 24,000, which is the max RPM for this spindle. Now, does that mean there's something wrong with your electronics? No, it doesn't. This is totally normal. So now what we're going to do, and we can even do this with cycling down. And cycle it all the way down, turn her off, and now you'll see her stop. Once again, if we check voltage, should be down to that 0.4, so to speak. Let's see. There you go, 0.04, 0.041. So again, the more accurate your multimeter is, the more you're going to see those decimals to see exactly where your voltage lies. But what we just demonstrated is how you can check yourself your voltage PWM output on not only a G540 but any drive. This information once again is applicable to any drive or any breakout board. Testing this voltage and looking for that variance, because once again we're at 9.44 volts here, even though we're getting 9.96, 9.97 on the VFD, that's going to give you your total RPM output when your VFD is configured properly. And I'll say that again. The VFD must be configured properly at the right hertz, which typically is 400 on an HY VFD. And once again, that will give you the allocated maximum RPM, or or close to it, depending on the voltage output from your PWM in this case. And that's why we're getting, what, 22.8 and change? And then this maximum RPM theoretically should be 24,000. So now you can see how to do this test yourself. And this is why, once again, on my systems, I try to make everything to where it's accessible in a hooked up format. Meaning I have all my cables connected and am still live able to check all the voltages because I'm using a solderless connector here with the screw heads right on top, and you can see those screw heads right there. So these are fully conductive. All I have to do is put my probe tips there and I can take full measurements. Very, very neat, very efficient, and it helps not only me, but now you guys can take this information and check with your own system. Do not panic if you notice that your system is showing inside of Mach 24,000 RPM. That's what you're putting in, and you're off slightly. Because how slightly are you off? Now, don't get me wrong. If you were off here, 3,000 or 4,000 RPM, something may be wrong. If you're not off 3,000 or 4,000 RPM, and in this case we calculated, I believe, 5%. Mm-hmm. Okay, so if we're off by 3 to 5%, that's normal because of efficiency. So that's exactly what we have here, and that's exactly what we've defined. Now, to show you that the spindle works in both directions, because I know I have guys that always ask me that, we're going to just lower our speed because there's no reason to break the sound barrier. Okay, we'll go here. Bring this up. Okay. Now we're at 5,000 right there. And if we go to MIDI and I type in, now look at forward, it's going to stop and then it reverses. So this is perfectly configured. I'll now go back to M3. Now it's going to reverse again and go back to forward direction. And we're running in the same RPM. So again, this system is configured perfectly for Shan. He'll be all set to go. And you guys now have valuable information with your own systems to check and validate as you're building your system. Do not wait until the end, like so many guys do, and build everything and put everything in their, direct places. Test as much as you can outside of the system. The more you can do that, and do it in a neat fashion. I've seen guys do setups where everything is crazy. Thank God I have a little more space than most, and that makes it easier for me to allocate, but really think about your test setup, because the less confusing it is, the easier it is for you to allocate and understand exactly what's happening. Work in a system, one piece at a time. Cycle power to one item, the next item, and go forward. And then if you really want to learn really fast, I recommend documenting everything. The more you can document, and now you can do it real easy with your phones, it makes things much, much easier. Let's turn the spindle off, go back to program, and we are now all set to go. We'll kill the power to our fluke, kill the power to our system right here. We'll leave the UC400 on, because if we leave the UC400 on and we're in Mach 3, we're not going to get that error that Mach 3 is detecting that the system is off and not communicating. So now we'll pull out the plug on our VFD. And like I said, systematic. We work in a system. Now you guys know how to check your voltages on your PWM. I have to be honest, I don't think I've ever seen a video really break down the G540 in doing that, and that's why I was adamant about doing this. On top of the fact, I know, once again, and I've said this now, this will be the third time, this information is redundant towards any drive or any type of breakout board that's using PWM. You can measure these voltages. Once again, I highly recommend a quality multimeter, because slight voltage variances are going to make a huge difference. You've just seen that. So again, I hope that this video has been helpful. Of course, this is a test setup, and I'm making that known because I will have certain guys that'll feel like they have to tell me my business, and I already know this is a test setup. What I'm doing here is setting it up for the client in the easiest format to make sure that when they get everything, it's as plug and play as possible. So again, I hope that this video has been helpful. Thank you for your support. If you guys have questions dealing with this or any other topic with controllers, electronics, I get them all the time, realize this: it is virtually impossible for me to clarify and determine what your problem is by a long string of email where usually there's no type of punctuation done, the paragraphs are just never ending. I need to sit with you and see what's going on. I am not going to be a mechanic working on a car without it in front of me. You have to think like that. So if you're serious about correcting an error in your system and you don't want to do it yourself, yes, you're going to pay me. Yes, we're going to work on it together and you're going to learn something, because that's the whole idea of doing this. And that is exactly what you're paying for. So just realize where we're going with this. And once again, I want to thank you all for your support. Take care.